In this video, we're going to talk about topic 5.6, example 3, and we're going to notice that we need to find the open intervals where we are concave up and concave down, and find any x values where we have a point of inflection, and then give a reason for our answer. So I'm going to take the function, and I'm going to start by taking the first derivative, which would be 4x cubed minus 6x squared minus 24x. And then I'm going to take the derivative of that. So it'd be f double prime of x equals 12x squared minus 12x minus 24. And I'm going to set that equal to 0 to get my critical numbers. I notice I have a greatest common factor of 12. So I'm going to pull that out. I get x squared minus x minus 2 equals 0. And I'm going to use a good old magic x. I need two numbers that multiply to -2 and add to -1. And that would be -2 and 1. So I get 12x minus 2 times x plus 1 equals 0. I'm going to set all of my factors equal to 0 by the zero product property. And I notice that this is x equals 2 and this is x equals -1. So that one doesn't have an answer. So these are my critical numbers. I'm going to use those in my sign chart. So we've got the intervals, not the x's, the intervals. So I'm going to start at -infinity, and my first fence is at -1. My second fence is at 2, and then I go all the way to infinity. I am going to pick x values. So in between -infinity and -1, I'd probably pick -10. Between -1 and 2, I would pick 0. And between 2 and infinity, I would probably pick 10. Then I'm going to plug into my second derivative, my most simplified form of my second derivative, which would be this right here. We always know this first term is going to be a plus sign no matter what. So this second one, when I plug a -10 in, the -10 is going to make that one negative and make this one negative. So a positive times a negative is negative times a negative is positive. Then I'm going to look at plugging in a 0. So when I plug in a 0 to this first one, it's negative. And when I plug it into the second one, it's positive. So a positive times a negative is negative times a positive is still negative. Then I'm going to plug in a positive 10. So 10 minus 2 is going to be a positive, and then 10 plus 1 is going to be a positive. So positive times positive is positive. So what this means is anytime I'm positive, I am concave up. And anytime I'm negative, I am concave down. So we're going to go ahead and write this out. So f is concave up on the intervals from -infinity to -1 and 2 to infinity, because the reason is right here. F double prime is greater than 0 on these intervals. And then f is concave down on -1 to 2, because f prime, again, I'm looking at f double prime, is less than 0 on these intervals. And then we're looking for points of inflection. So anytime I had sign changes, I had points of inflection. So f has points of inflection at x equals -1 and 2, because f double prime changes sign at these values.